All right, it's about 12 o'clock. Guess we'll go ahead and get started. Hello, everyone. This is Michael McClellan. I am your chair this year for the IEEE, the Atlanta chapter of IAS. I hope to do a job for you. We have a couple announcements. We have a new member of the IEEE IAS committee. Our secretary is now Jason Page. And so we're excited to have him aboard. This has been trying times for all of us with the COVID-19 pandemic, and we're going to do the best we can to make sure you guys have an informative presentation. Wish we could do all the socialization that we were used to at Maggiano's, but it's not really possible, unfortunately. But if you guys could think of anything that we could do better to gain more membership or to improve the IEEE IAS experience, please let us know. You can email any of us. I'm sure you guys have emails for me or our vice chair, Mariano Rojas, who is with Cummins, Lucian Gavrulik, who has his own firm called IPA, and Jason Page is with Kojima. And this is a webinar in webcast format, and that means that your phones are muted. However, we really want you to ask questions and make this interactive like we do at Maggiano's. Ask questions. You can ask questions by using the button. For most of you, it's going to be on the lower left-hand part of your screen. For some of you, it may be on the right side. But there's a chat box or a question section. Feel free to use either of those. We would love for you to ask questions. We are very fortunate today to have, we have a very experienced speaker with us, and in a good way. Mark has been around a long time. He's been at the old Lockwood Green Company. He, I believe, was with Union Camp for a while, and spent the last 17 years at Wood Group, also known as AMEC Foster Wheeler, also known as AMEC, also known as, there's another name before they changed to AMEC, but yes, yeah. So we're all very fortunate to have Mark with us, and Mark is going to present on a topic that I've never heard presented before, so I'm excited, and that is non-electrical considerations for the electrical room. And at this point, I'm going to turn it over to Mark.
Good afternoon, everyone. As Mike said, I definitely missed the socialization that we experienced when we'd have in-person lunch meetings. I gained a lot of good contacts that way, but we do the best we can these days. Mike said he'd never heard this topic, and I'm sure a lot of you probably really haven't given any thought to this. I remember when I first went to Dave, Mike's predecessor, and said, here's the topic, and you know, I'd be interested in presenting. And he said, what do you mean, non-electrical considerations? You're going to find out that I'm not going to mention any calculations regarding cables or ampacity or things like that that we do in our normal everyday business. Hopefully I'll give you some pointers, some eye openers. So what really drove me to dig into this topic initially, there were a couple of situations that occurred in some of the projects I worked on in the recent years. One of those projects, we had an air core reactor that had been placed on a platform. It was outdoor rated, and the drawings came in. The reactor was, as usually happens, slightly bigger than the initial drawings, and we had to put a fence. We put a fence around it, non-conductive fence, by the way. And the issue that we had was, well, the platform was already built, the reactor was shipping. Do we have enough room to actually get around it? So right there, that's non-electrical consideration. The other project that I'm probably going to lean on a fair amount during this presentation, we had a couple of combustion turbines that we were putting on a site out in Texas, about 60 miles northeast of Houston. And there were several interesting issues that came up with that. I'll talk about those as I get into the presentation here. And you're going to hear me flipping pages. The big advantage of doing this from home is I've actually got a table with my slides laid out and all my notes. And when we post this, I'm going to send Mike the PDF of the notes pages as well, so you can see there's going to be some hyperlinks in there to some information some of you may be interested in. So whenever you go to a presentation, come on. There we go. You always get hit with learning goals. So the first thing I want to do is, as engineers, what a definition of engineering is art of or science of making practical application of the knowledge, yes, I'm reading this, of the knowledge of pure sciences such as physics or chemistry and the construction of engines, buildings, mines, ships, bridges, plants, etc. A code, I want to go ahead and identify what a code and a standard are. Code is a systematically arranged, comprehensive collection of laws. A standard is an acknowledged measure of comparison for quantitative or quantitative value or a criterion. So those are the things that we've got to do. We're held to do. But there's other issues that that you can get into, what I call non-code coordination issues, and they actually are of two different types, if you will. One of those might be methodology. How are we going to actually accomplish, what's our methodology? How are we going to accomplish our goal here? The other thing that you actually do is you get into the physical interferences that can occur with electrical rooms. And last but not least, many places that I've been, Lockwood Green, Wood, Wood's predecessors, they had checklists, and I'm also running to folks that worked at other companies, Serene, Jacobs. They would have checklists that they would use when they were going over documents, the published documents, so that they would actually know things to be looking for. So we want to talk about electrical rooms and the non-electrical aspects. Now, I've got a friend of mine that missed his calling. I understand he's listening today. He really should have been a comedian, but I guess he decided that engineering was probably a more lucrative, more stable occupation. So he actually provided me an edition of a, oh, the word slips my mind, a definition of what an electrical room is or what it's not. I'm going to read this to you. According to project managers, the best place for an electrical room with several pieces of switchgear and MCCs in it is actually a shared space with a janitor's closet and the electrical equipment preferably being mounted on the ceiling so that the janitors can access their cleaning supplies. And by the way, this cartoon, if you Google, I know most of you probably seen this or some variation. The very first variation I ever saw only had 6 pictures in it, but if you Google how the customer wanted it cartoon, you will find several versions of this cartoon if you ever want to have a little funny to hang on your wall in your cube or at home nowadays, I guess, with COVID-19. So we kind of described what an electrical room we don't want it to be, but what is an electrical room? Well, I went and looked for a definition of electrical room. There's no definition in the National Electrical Code. There's no definition in 70E, the Electrical Safety Code, 70B, which is the Electrical Maintenance Code. Finally found a definition in IEEE C2, which is the NESC, or the Utility Code, if you will. And one thing I want to point out to you, if you look in the right hand, about the middle of the picture on the right hand side, you'll see that this is not, there's looks like a pump over there, some type of piping. So this is not necessarily a totally enclosed room. The definition that exists in the NESC, any building, room, or separate space within which electric supply equipment is located and the interior of which is accessible as a rule only to qualified persons. So this is an electrical room here, even though it's not completely enclosed or doesn't only have electrical equipment in it. Now, we do want to, because this is going to come up a little bit later, I do want to point out that there was a definition added in the NEC 2020 of an electrical datum plane, a specified distance above water level above which electrical equipment can be installed and electrical connections can be made. I probably won't come back to this definition, but that'll come up again a little later here. And here is an example of a completely enclosed electrical room. I'm sure many of you have seen something like this. This is actually a 2-story version thereof. I've seen a lot of different names for this. Some of you may have seen something different from what I've got listed on the side there. Integrated power assembly, power control room, power distribution unit, power distribution center, e-house, electrical control room. So now that we've established what an electrical room is, let's get to the non-electrical aspects of the electrical rooms. What do they interface with? Well, they primarily interface, when I was putting this together, I thought of these listings here as, back when I learned chemistry, there were 3 phases to a substance. There was the solid phase, the gaseous phase, and the liquid phase. And they kind of equate, if you will, to the civil, structural, architectural, or the HVAC, dust, fume control. And even though you may have a solid that you're handling, the solid is probably flowing, so that covers the process and materials handling. And then piping obviously has the liquids involved contained within it. I want to stop here for a second and digress slightly. Hold on just a second. Let's there's also secondary considerations that we interface with. We can interface with the I&C folks, or we can interface with fire protection. And right before I moved on, I realized I needed to click for this. I don't know how many of you have ever seen, I personally have not, a shutdown. I've seen a shutdown due to a water leak, okay? But I've seen it from outside the room where something happened, water got blown into the room, or it was a bad rainstorm. But I have never personally known of any leakage within an electrical room that shut the equipment down. And the reason, I'm going to come to that later on, because that's got to do with fire protection. I have seen a heck of a lot of shutdowns, or am aware of a lot of shutdowns due to animals such as snakes, rats, squirrels, etc. So think about that for a little bit. Mike, can you hear me okay? Is everything, we got any feedback? Anybody have any problems?
I hear you great.
Okay, thank you. All right, so I'll let everybody take a look at this picture here. And what I would like for you to do is think about the picture, and I named off basically 10 areas of coordination that we've got to have. There are actually 7 of those in this picture identifiable. One of them is not necessarily readily identifiable. I'll let you think about that for a second. And here they are. It's possible, we briefly mentioned this a moment ago, to have piping in the ceiling. Obviously, we got to interface with our HVAC folks, their ductwork up there. I could be wrong, but I'm pretty certain that's a fire protection panel in the back there for smoke detection. That panel that's against the wall in the back right-hand corner, I'm pretty sure that's a instrument control PLC panel, something like that. I've got process here on the MCCs. Well, how do we interface with that? Well, when we set up our MCCs, we've got hopefully an equipment list listing all of our motors. So there's an interface with those folks. Architectural, got to be able to get around the end of the switch gear. And I mentioned this with the air core reactor issue that I had. Same thing here. How much room do I need to get around the end of that? Then on the floor, you notice that the MCC and the INC panel, the switch gear, all of those are actually on what I call a housekeeping pad. I do not know, this is not, I just found this picture on the internet, so I don't know where it actually is, but a lot of plants that I've been involved with over the years, use a 4-inch pad to put the electrical equipment on to keep from, if there's a potential for flooding or something, keeps the water from getting in the bottom of the gear. The thing that you do have to be careful with, if you do that, you got to be careful with how high you raise it, because there's the limitation of how high the handles can be in the on the MCCs. I think, if I remember correctly, it's 6 foot 7 inches or 2 meters. Try to get us into the metric age. Now, we hadn't seen the other picture, but we have seen this picture already. It's a little bit more expanded now because I don't need the room to put the information on the side. take a look at this picture, there's actually 4 different interfaces in this picture. And one of them we kind of touched on, 2 of them we already kind of touched on before in the other picture preceding this one. Architectural we touched on before, but we got a different issue with architectural here. This picture cut off on the left-hand side, but we have no clue what's out to the left of us, but there is a potential that we might be right over a chemical process in the next building that could be exhausting out the side of the building and sucking it right into our electrical room. So we've got dust fume control there. Obviously, we got to have some type of support for this building, independent support, so we got to interface with the civil folks. And I'm not sure, I believe this is probably cable tray. I really didn't zoom in on it to take a close look, but what that brought it to mind when I saw this in the lower right-hand corner, when I saw this was, well, where did they put this structure and where do these steps actually exit to? There may be a forklift running in between the 2 buildings or transporting material around in front of this electrical room. Well, first thing we've got to do is we've got codes and standards that we must meet as professional engineers. So in the state of Georgia, I decided to take a look at the state of Georgia and see what they require. This website will be, there's a couple of websites associated with this actually. It will be in the notes pages. If you go to the Georgia Department of Community Affairs, you'll find mandatory codes listed. One of the big ones that I'm going to hit is the International Building Code. Look at the superscript on the International Fire Code is another one, and the website refers you to the state, the DCA website refers you to the state fire marshal's website. The reason the ones are grayed out, that's International Plumbing, Mechanical, Fuel Gas Code. What I did when I worked on this presentation, I specifically looked for the words electrical room or electrical equipment room within these codes as best I could doing PDF searches. So those 3 do not have any reference to electrical room, electrical equipment room, something like that. In the National Electric Code, Georgia State right now is under the 2017 version of the NEC. I have not been able to confirm this, but I did see a blurb on one of the Code Watch websites that I follow that's indicated that the 2020 code will be adopted effective January 1st next year. And then the last code there, I'll touch on the International Energy Conservation Code. And you'll notice that these Georgia codes on some of these have amendments. And if I remember correctly, the 2017 NEC did not have any Georgia amendments. And you go to the State Fire Marshal's code, State Fire Marshal's website, and you'll see that I'll let you look at the verbiage there yourself for X amount for the top there, but you notice that they adopt 177 codes. So if you're having trouble falling asleep, hopefully I haven't put you to sleep yet with this presentation, just go read that. 177 codes adopted. I'm going to touch on the ones that are on the bottom in this presentation, and a couple of them that I didn't list here, but the International Fire Code, NFPA 13, NFPA 72, and 101. I would also like to point out that NFPA 70E, the standard for electrical safety requirements, the arc flash code, as we call it, a lot of times, is actually adopted by the state fire marshal, and it's adopted with modifications, the 2018 version thereof. All right, let's move on and do our breakdown from a few slides earlier. Talk about civil, structural, architectural, and there's actually codes and standards that we've got to look at, and then non-code issues that we need to consider as well. So the very first thing that you got to look at is International Building Code, Chapter 3. There's two things that affect how a building is classified or built or whatever. And one of those is Chapter 3, the occupancy classification. There's 10 major groups. 6 of those have breakout by use. And I've given an example there. And you notice that the swimming pool, there's two different uses, if you will. It's the same classification, assembly group, but the use without spectator seating and then with spectator seating. So if you got a bunch of for the Olympics, when they built swimming pools down at Georgia Tech, they obviously wanted spectator seating, so that would have been assembly group A4. One of the groups that has no breakouts is the educational group E. The other 3 are business, mercantile, and utility, or utility and miscellaneous group. I want to bring up the point. There is no special occupancy classification for electrical rooms. And the other thing that I briefly touched on, I don't have an individual slide, but it is in the notes section. The other thing that affects buildings and how they're classified and the walls are actually built, etc. There's the IBC Chapter 6 is types of construction, and there's actually identified as types 1 through I through V, Roman numerals is what they use, but it's 1 through 5. And they are kind of defined by the combustibility or the fire resistance rating of the interior walls, exterior walls, roofs, load-bearing walls, etc. And the NFPA equivalent of Chapter 6 of the IBC is NFPA 220. It actually uses constructions type I through V as well, but they don't equate to the IBC. However, the state fire marshal actually has a nice little chart that equates them for you if you go to that website that I have in the notes section. So we touched the IBC that covers civil, structural, architectural, and going a little further and taking a look at stuff that's civil affected. Chapter 16 is structural design, and it's got about 3 or 4 sections initially that define, as you can see here, 1603.1, construction documents shall show geotechnical information, load-bearing values of soils. And I mentioned that the first 3 or 4 sections of Chapter 16, actually are kind of general, and then there are sections such as Section 1610 on these different things that the construction documents are supposed to show. So 1610 is soil lateral loads. And you ask, well, what does that how is that a non-electrical consideration? Well, the interface that we're going to have there is, I showed the picture of the electrical room sitting on beams, sitting on some type of support on the ground. Well, a lot of times these electrical rooms are actually put on piers. And if you want to come out of the bottom of that electrical room with your tray, your cable exit, you're going to have to coordinate with those piers, if you will. Then I've got flood design data. The project that I mentioned that I worked on was was northeast of Houston. The desire of the client, obviously they get hurricanes. And I remember Houston a couple of years ago had something like 54 inches of rain in 3 days. I don't remember the exact figure, but our client wanted our electrical rooms above the flood zone. So how does that affect it? Right there. Another civil and also affects structural is earthquake design data. There's risk category. There's several things that go into the earthquake design. This risk category, those are A through D, and then there's a couple of special categories, E and F. They are also based on the risk category, and if you got some really high spectral response acceleration parameters. I managed to say that without tripping all over that one. The last one is a seismic design category, and I'd like to point out, I saw vendor documentation fairly recently that used the term design zone. That's no longer in use. So if your vendor hasn't given you a seismic design category, you need to go back to them and say, hey, I need this updated. And there's a few other factors that have to be shown, but these are the most important that I've got listed here. And then the equivalent to the for the listing here, the design data, the entire section is 1613 earthquake loads, and it actually refers to ASCE 716, and it specifically mentions chapters 11 through 13. And they are of some importance to us, so I want to jump to those here. Chapter 11 of ASCE 716 is seismic design criteria. And notice it says design and construction, building and other structures, and in the scope, structure, portion thereof, including non-structural components, shall be designed and constructed, etc., etc. So we jump, and how do we get to buildings and how do we get to the non-structural? Within there's 2 chapters in the 716. One of them covers building structures, and this, I know we had a presentation a few years ago. Someone came in and spoke about the earthquake testing that they did on switchgear and other electrical components, and this is how they got there. You see chapter 13, non-structural components, and the seismic design category, the last paragraph there, non-structural components shall have the same seismic design category as the structure they occupy. So moving into more of a pure structural criteria, if you will, codes, requirements. You see we've got floor live load, and there's 3 different loads that are listed there: uniformly distributed, concentrated, and impact floor live load. Now, where this concentrated can come in to play is when you've got something like a battery bank, especially when they're stacked 2 high or 3 high. Those things get pretty heavy real quick. I remember doing a a project up in Chattanooga. We were installing a lighting UPS, and we had to go to our structural group and say, hey, are we going to be able to put these batteries on this floor? We were on a second floor mezzanine type type area that we were retrofitting and installing the UPS, and we actually ended up having to put in a couple of structural beams to support the battery load associated with that UPS. Next thing that I want to touch on is the snow load data. You would be surprised. The thing that really, most of my projects have been in areas that really haven't had to consider snow load. Desert areas out in California, I mentioned Houston, they just don't get a lot of snow. But fairly recently, I started doing some work in Virginia, and obviously snow can be a factor in that area. So that's why I've got this one specifically called out, and the situation I had was not an electrical room per se. We were looking at running cable tray and a solar photovoltaic. Instead of going underground, they were looking at using cable tray for the distribution. And I saw in one of the cable tray design manuals, you might need to take a look at the snow load. Well, I got with my CSA counterpart, and he said, yeah, here's the snow load. Believe it or not, the snow load for that tray was actually 1.5 times greater than the medium voltage cable that was going to be in that tray. And the last item I have, bullet point here on this slide, wind design data. Obviously, coastal areas, you're going to have hurricane design. We can see that the winds, the hurricanes can actually come inland. I mean, we had some pretty good winds around here a few days ago from Hurricane Sally. One place you may not think about it, I did a project back in 2006-07 timeframe out in California. It was a cement plant, and it was in the high desert. I remember going out there to the construction trailer, and construction superintendent said, we're losing CD drives. The wind would blow so hard, and it would blow the sand and cement. It was, like I said, it was a desert area. It would blow the sand and the cement particles into that trailer, and they would get in the disk drives, and they were tearing the disk drives on the computers out. Jumping on over to architectural, this is one of the things that we always have questions about. So I'm going to touch on this as best I can, but trust me, I am by no means an expert on this. And please don't ask questions. I'll refer you to the architectural department every time. First, you notice there's a chapter on firewalls, and the fire resistance rating shall not be less than, got the table there, and you see we touched on the occupancy classifications. Well, that's what these on the left-hand side are, the A, B, C, et cetera, and some of them, like the A, every assembly group, you have to have that fire resistance rating. Now, I'm going to read this because this did come from one of my former architectural colleagues who was kind enough to review and make comments. Firewalls, true firewalls, are fairly rare. They're very complex and expensive to construct. The typical electrical room required to be fire rated is likely to be surrounded by fire separation barriers or fire separation walls, which are cheaper and much closer to normal construction. And I do have that verbiage included in the notes page. So, okay, take a look at fire barriers. And if you notice, there's only a couple of groups that actually have a fairly high fire resistance rating there. the H1 and H2, which are hazard, and those are pretty high hazard areas. I don't know remember exactly what they were. And you'll notice that I've got the fire areas for single occupancy. If you got a multiple occupancy, you got to go another route, which I definitely don't have time. I did not include a slide, and it's a good thing I didn't, because I still got quite a bit of information to go over. But if you go to this chapter, it'll give you the right place to go for multiple occupancies. Something that I threw this in here because for a long time I didn't know where this existed, and finally ran across it, and I always keep it handy. For those of you who haven't seen this, now you've got a place to go to look for it. There's a factory mutual data sheet 5-4. We can go to the NEC, and if we've got a transformer inside a building, well, we know what to do with it. The NEC prescribed that to us. But a lot of times you get into the question, how close can I, if I'm outside, where can I be? How close can I be? And what kind of construction do I have to have? Well, I'm not going to go over this, but you'll notice that it's broken down by, is it a non-flammable? I kind of hate to use the term non-flammable, but is an approved liquid from FM, or is it like mineral oil would be a non-approved transformer liquid? And obviously the distance varies depending on what kind of fluid you got a liquid fill, what kind of fluid, how much is actually in it. I would like to point out that notice it does not say fire wall. It says 2-hour fire rated wall. So it's not a true firewall. It is a fire rated wall, or I guess this is their equivalent to the fire barrier wall. Another architectural comment or architectural coordination is the means of egress. And got another slide coming up after this one where we're going to talk about a couple of things. But if you remember the picture of the standalone room, there were two things on there. One of those I had actually called out, but I don't know how many people noticed. There was actually a light in the lower left-hand corner, and there was a doorway there. A lot of the other openings were probably to the back of gear, but there was actually a doorway there. And this particular paragraph here makes me think that room's not quite complete, because if you'll notice, it says single step with maximum riser of 7 inches. And this is different from NFPA requirement, which NFPA 101 requirement, which I've got in the notes page. I'm not going to touch on here. So you can't, if you come out of a door, you can step down 7 inches. If it's larger than 7 inches, you got to have a ramp for accessible handicapped people, or I think you could probably use in the picture that we had, you probably could use a set of steps. And you notice that there was a stairway landing on the top level, and here it is, floor or landing at the bottom of each stairwell. Now we're going to get to what kind of room do we got to have to actually get around or through. IBC gives us this table right here, and I didn't pull in the whole table because thankfully the piece that I wanted was on the top. You see the middle item there for occupancy, 24 inches. Now, NFPA 101 talks about minimum width of corridors being 28 inches. So this would be a place where you need to coordinate with your architect, say, which code are we using? But this gives you a little guideline. And when I was looking at this, I actually went to the NEC handbook 2017 and looked at the pictures that they've got for the large switchgear, the 1200 amp switchgear. I could not find anything in the informational notes or the explanatory material in the handbook that actually gave you what the width of that around it needed to be for your escape path. So the non-code issues, we touched on some of these a little bit before, but you need to coordinate your wall penetration with your architectural, structural people. How big is it going to be? Where is it going to be? How many do I need? If I'm going through the roof or through the floor, I only have floor penetration, but the same thing would be for roof penetration. If you're actually inside of another building, size, location, then how much overhead room do I actually need? Now, it's not required that it be 6 foot, but if you have at least that much available, it has to be 6 foot of dedicated electrical space above MCC, switchgear, panel boards, et cetera, et cetera. And I threw that little blurb in there to make you think about it. That's not a lot of room. You may want more than that 6 foot, because if you've got a cable tray, 3 trays with 6-inch side barriers, and you want at least a foot between them for access to the cables in the tray, you already got to 1.37 meters, 4.5 foot. I mentioned the project that we did out in California. One thing that we ran into was we had prefabricated buildings that we used out there, kind of a stick built, but they were prefabricated, bring them on site, put them together. And we ran into a little surprise. The wall load on those was not capable of supporting very much. So a 75 kVA wall mount transformer for a lighting transformer, we actually had to build a little platform or support structure for that transformer, because we could not just hang it on the wall, if you will. We talked about the housekeeping pads in one of the pictures. And the other thing that you can get into is, does your switchgear require leveling channels? So you got to coordinate that. If you got a 5 kV gear, you may very well, or 15 kV gear, you very well may have leveling channels under that gear. And we've covered the bulk of the material, a large portion of the material under the CSA, but we've also got our other folks. And in this particular instance, there's no non-code issues that I'm going to touch on, but there are a couple of code issues, if you will, that I want to touch on. Now, the IEEE really doesn't contain a lot, actually none, in my mind, for electrical rooms, but the only thing I could find was there's this section C401, and this is the 2015 code in Georgia, by the way. And it talks about commercial buildings shall comply with one of the following. Well, me not having access to the IEEE except for online, that's kind of hard to search. But I did have a PDF access for the ASHRAE. And if you'll notice, it's actually ASHRAE joint produced standard with the Illuminating Engineering Society, IES. This is the only reference that I could find to actual words, electrical rooms, within that document. Lighting power density allowance. Okay, Now, one of the things that I get into, particularly when you've got standalone electrical rooms, and we had this on the Houston project that I mentioned, the smoke detectors were interlocked with the HVAC units for that. And they got me to thinking, where do you actually find that requirement? Well, the only, or the requirement that I found was NFPA 72, but you'll notice that it doesn't actually tell you you've got to interlock it in this case. It just talks about various types of interconnections. So, unfortunately, I can't give you a lot of hard data, if you will, on this, on how to do that. And yeah, that's kind of electrical in nature, but that's not necessarily, that's not a cable calculation or anything. That's a more of a process type interface. The one place that I did find a prescribed interlock was, this is a new section in the 2018-2019 NFPA 72, as 21.8, and it refers to NFPA 13. So I actually went and found where's the corresponding portion in 13, and here it is. All HV, high volume, low speed fans shall be interlocked, shut down upon a water flow alarm. That's the only place I could find where there was actually a prescribed interlock for an HVAC system based on any kind of a fire protection. Yes, I've jumped back to the NEC, but in the NEC under batteries, we get referred to a couple of other standards in the informational notes. One, NFPA 1, which is not adopted by the State Fire Marshal, by the way. There are no interlock interconnection requirements. And then there's a IEEE cross-listed with a ASHRAE Guide 21. There's no requirements, but it does mention potentially interlocking your battery charger with outside airflow. Non-code issues, obviously we touched on the distribution ductwork, where your air vent's located. Something you may not think about is whether you've got to have independent AFD or adjustable frequency drive cooling for your drives. A lot of times that'll be on the medium voltage. It's possible to have a rather large low voltage AFD that you may have to have special cooling for. And of course, one of the things that we ran into in the Houston project, our electrical room was located next to, one of our electrical rooms located next to a pipe rack. And I kept telling them, hey guys, we got to be careful. We can't exhaust this arc flash. And sure enough, even though we told them, they sent it in, and the arc flash exhausted right next to the pipe rack. So we had to go and say, okay guys, we got to do something special here. Had to work with them on that. As far as the material handling, I'm actually going to skip through this because I want to get to, and I'm looking at my time, I want to get to the very last portion of this. So I'll let you look at this at a later point in time. But one thing that I do want to touch on real quick, sometimes the second bullet point, removal egress for equipment, sometimes something that's not even in the area of our electrical room or within, say, 50 feet of it can actually affect what's going on. And you ask, how did that happen? One of the projects that I was not involved with, but I saw a couple of years ago, maybe about a year ago, our CAD designer came to me and said, look at this. He said, they've shrunk the room. I said, what? I said, all this space that we had identified as future, we don't have it anymore. They shrunk the walls. I said, well, what's going on? So I went to the lead engineer, and as it turns out, the electrical room was being retrofit into an existing building, and or it might have been being added onto an existing building, but what happened was the electrical room was next to a generator floor, and they needed the room. They had the columns they were using to support that second floor. They had to position them a certain way and move them around to actually have room to bring the shaft out of the generator and turn it so that they could get it onto the road to transport away. So sometimes we don't, there's things that are completely outside of our immediate sphere of influence that we have to take a look at as well. Last but not least, going to touch on non-code issues and then some standards here. So when we're taking a look at, this is more of the methodology that I identified early on. When we take a look at instrument control systems, there's a lot of things that we kind of need to get ironed out, if you will, with our friends in the I&C world. We're going to have a separate rack room. We're going to include a rack room in it within our electrical room. How does that affect our heating and cooling loads for our HVAC people? What kind of power requirements do they need for their instruments and their processors? And I hate the word emergency because people misuse that so much in the industrial world that I've been exposed to. Identify it as an essential or a process safety requirement, not as a emergency requirement when you're talking about UPS power. Of course, what type of I/O are you going to have, and are you going to use Ethernet? And I mentioned the Houston. I'm going to use the Houston project again. Obviously, we had a lot of issues on it. We had purchased smart MCCs, and the client came back and said, hey, we don't want to use that. We want everything to be hardwired. And that ended up forcing us to put in a larger control wireway, which obviously affected our room that we needed for our architectural folks for the access to the cableway. Okay, let's talk about the thing that I have avoided and put off until the end. Fire protection. I want to talk about sprinkler ratings because one of the things that people get fooled into are our friends in Hollywood. They show us the MacGyver effect, where the guy holds up a cigarette lighter or match or whatever and sets off the sprinkler, and all the sprinklers go off. That doesn't happen. You'll notice that I've got these are a manufacturer and his model of sprinkler heads, and you'll notice the operating time of those sprinkler heads. Now, I don't know about you, but if I held a match for 9 seconds, I'd probably burn my doggone finger, throw the thing down. Same thing with a cigarette lighter. You see the people waving them around at concerts. You see the pictures of that. Well, they're waving them around, so they're actually introducing airflow to cool it off. I bet they would probably not stand there and hold it open for 9 seconds, just holding it still. Okay, I found out that I've got to end the meeting. So I don't know if we'll be able to do the questions or not. That said, Michael messaged me. So that said, let's move on to this other slide here. The other thing I want to look at is the sprinkler ratings. If you'll notice, the temperature rating just on a ordinary sprinkler head is 135 degrees. Now that RTI that's up there, that's what's called a response time index, and sprinklers are rated to that, for those. And you'll notice the quickest one was at 9 seconds. And what happens here? I talked about, the holding it still. The definite, or what I found, a blurb on the Wikipedia site under standard testing procedures. So 135 degrees air at a velocity of 8 feet per second, or that's 5 miles per hour, the 68 degrees C sprinkler bulb will break within 7 to 33 seconds. So sprinklers have got to have some type of a heat transfer mechanism. It's got to be pretty warm. They're not going to go poof and wet your electrical room down without some kind of provocation. The last slide that everybody's going to be kind of interested in. In NFPA 13, electrical equipment, and you can read it there, but unless the requirements of the next section below are met, sprinkler protection shall be required in electrical equipment rooms. And that's kind of why I went over the sprinkler head ratings, to point out, hey, yeah, we always think, oh my God, water. Well, it's not going to happen that way. And then I've got all the conditions there, and I want to point out to you that I emphasized it's 2-hour fire rated enclosure. So it's not just the walls, your roof and your floor have got to be rated for 2 hours as well. Real quick, look at the learning goals. Hopefully we met all those learning goals. Let me see if I can don't see any. I don't see any questions. So hopefully everybody had a chance to learn something. This will be posted on the website. I'm not sure how quickly it'll get there, probably within the next week. I appreciate you sticking with me. If you're still on, I do want to point out that this was non-electrical considerations. Hopefully I've kind of proven the point. There's a lot of things to look at, and hopefully you've got your eyes open to some of the things that are out there that can cause us grief. Thank you everybody for attending, and hope you enjoyed. And I'm not exactly sure, but it will be on the 3rd Monday of next month, October, that we'll have the next meeting. Are you back, Mike?
Hey, Mark, this is Luchi. Can you hear me?
Yeah. You take over?
Yeah, I've taken over from Mike. Mike was in a bad spot for his cell service. So I would like to thank you on behalf of the IEEE board team for the presentation. I definitely learned quite a few things from your presentation. So appreciate everybody. Also, I would encourage the attendees to email Mariano Rojas, if you have not received a certificate for this presentation, we're still navigating on how to save everybody's emails, so we can forward that to you. But we definitely appreciate if you can send that. If you haven't received that, we'll send that email out and we'll get it to you. All right, so you've got a couple of things here to you. There were some couple of thank yous. Definitely, yes, this is a broad topic. We're dealing with a project right now that has to do with electrical rooms, and but this was very well put together for the amount of time we had. And again, for everybody else, next month we have a meeting, and it's going to be the third week. And we will look out for the presentation, for the email to come out. Again, thank you everybody, and have a great day.
Thank you, Lucy.